Hi everyone. Today I will present my paper. The title of my paper is T-VSL Text Guided Visual Sound Source Localization in Mixtures. I'm Tanvir Mahmood. My collaborators are Yapeng Tian and my supervisor is Diana Marculescu. I am from University of Texas at Austin. So let's introduce the problem of the visual sound source localization. So here we can see we have a multi-source image, a mixture audio, and then both of these image and audio goes into the visual sound source localizer, and it localizes the sounding region of the cat and also sounding region of the dog. The potential applications are locating the sound sources in videos for autofocusing the camera. And also this project aims to mimic the human audiovisual perception to introduce in autonomous agents. So there are some key challenges like the chicken egg dilemma, like for whether we should separate the sound first or should learn the correspondence of audio and visual modality. Also, there exist significant limitations of annotated samples, mostly in case of multi-source mixture localization. Let's discuss the limitations of existing methods. The key limitation is that there exists lack of annotated audio-visual pairs of sound sources, and we observe significant performance drop on multi-source sound source localization. And learning audio-visual correspondences in mixture is very challenging for the lack of supervision, and we have to learn the separation of sound sources and their correspondences internally. And most existing methods mostly rely on enumeral encoder that lacks audio-visual feature grounding. So the key research problem is that how to locate or parse sound sources in visual modality from multi-source audio mixtures without having direct one-to-one supervision. The highlights of our method is that we have a three-stage framework for audio-visual sound source localization. Firstly, we detect the single-source trimodal class instances present in both audio and visual modality, leveraging the text modality. And the next stage, we disentangle single-source audio-visual features based on the detected class instances. In the third stage, we learn audio-visual single-source correspondences for locating the sound sources in visual modality. Firstly, we detect the single-source class instances present in both audio and visual modality. We use a trimodal audio clip encoder for having a large-scale grounding between across all three modalities. Initially, we extract the single-source clean features of each class utilizing the text modality to use it as a feature guide. And audio and visual modality both contain some noisy features from multiple sources. For this reason, we fine-tune two projector to denoise these multi-source audio visual features. And we leverage this class instance detection module to utilize the text features to detect the class instances present in both audio and visual modality. We provide a multi-level class instance detection supervision for this task. Then we disentangle single-source audio-visual features from the noisy mixture features. As we said before, we use the text modality as a feature guide for single-source feature refinement. So initially, we extract single-source text features from the detected class entities, and these single-source features are iteratively used to refine the noisy audio and visual features from multiple sources. So as we can see that this refinement generates some single-source clean features of each sources, and we apply the supervision on these single-source disentangled features. Finally, we learn audio-visual single-source correspondences. So as we have seen, the disentangled audio-visual features now should correspond one-to-one. We apply the audio conditioning at this point on the disentangled visual features for further refinement and further alignment with the audio modality. And we apply a contrastive loss supervision between the disentangled audio single-source audio features and the conditioned further refined visual features. So here we put everything together, including the class instance detection, refinement of audio and visual features, and further audio conditioning into the visual modality. So here we compare the performance of our method in both single source and multi-source localization. And we use the same baseline method and metric as prior work. So we can see our method consistently achieves superior performance in both single source and multi-source localization across all metrics. Here we present some qualitative results. Firstly, let's check when both the sound sources are sounding in the synthetic mixture. We can see our method can more precisely locate every sounding source in this kind of mixture compared to existing methods. And also our method can precisely separate the silent source and detect the sounding sources, where most existing methods fails when there is a silent source. So in summary, we propose T-VSL, a novel text-guided multi-source visual sound source localization framework. We leverage the text modality to guide fine-grained feature separation and localization. Our method demonstrates notable robustness on challenging test mixtures with higher number of sources, and also we achieve state-of-the-art performance on both single source and multi-source localization. Thank you everyone.